So today we'll be talking about the coordinate system used by a connection builder. So let's say we want to make a connection between two beams, right? We have our beam number 1 and our beam number 2, and we want to create a connection. And say we want to create a shear plate connection with bolts on it. Now we need to figure out some sort of coordinate system so that we know which position to place the bolts and how far apart to place the bolts.
Now in Connection Builder, there's a help file that describes how the coordinate systems work. So if you just click on the Connection Builder icon and then click on the help button, it'll load up a help file. Now all I have to do is go to the search tab and enter coordinate, search for it, and click on Connection Coordinate System and Planes. Here it shows you how the coordinate system works. Basically, each beam has its own separate coordinate. So each beam has a x vector, a y vector, and a z vector. The x-axis is along the length of the beam. The y-axis is along the width of the beam. And the z-axis is along the height of the beam. So, how does this come into play in Connection Builder? And how does this come into play when we're making macros and connections? Well, let's put this in practice.
Say we want to create a connection between these two beams, right? Well, first click on Connection Builder, then go to the Connection Builder tab and click Build Connection. And let's call this connection Demo May 26. Okay? And we'll add a bolt first. Bolts. So these macros are existent within the Tekla structure macro. Now connection parts, we want to connect these two beams, part 1 and part 2. So part 1 is being main 0, part 2 being main 1. Bolted parts, we want to bolt a shear plate, which we'll create later, and part 2. So we'll fill in this part later. Now origin, we want to determine the origin as a point of reference, and we want to determine a vector x and a vector y. For example, if we set an origin at this point, at this particular point, then our vector and we set our vector x along this direction and our vector y along this direction, then we can say that our first our bolt on the top left corner can be how many spaces, how many x spaces from the origin and how many y spaces from the origin, so that we can set a coordinate for the bolt, and then we can set how far apart the bolts are. So for origin, let's set the origin to somewhere here. Now we click it open and we can choose planes. So we can pick the origin to be the intersection between several planes. Now what do these planes mean? Well, we know the x-axis goes this way, so the start, inter, and end planes are planes that intersect the x-axis. I've drawn the plane representations using a quick paint program. So here we have the x-axis along the length of the beam, and along the height of the beam we have the z-axis. The start plane will be the first plane, the interplane will be the plane in the middle, and then the end plane will be at the end. Similarly, and these planes intersect or is perpendicular to the x-axis. Similarly, for the y-axis, which goes this way, okay, we have the near side plane on the inside, the center plane in the middle, and the far side plane on the other side. And we also have the near side out plane on the very outside, and the far side out plane on the outside. And for the z-axis, perpendicular to the z-axis, we have the top plane, the middle plane, and the bottom plane. Okay, so going back to Tekla structure, say we want a origin here. we need 3 planes to intersect the origin to set it. So let's make the first plane the top plane, intersecting the z-axis. So first we want to select part 2 because we're dealing with the second beam. And then we want to select top plane. So we get PC2 top plane. Now we can check this to make sure we've selected the right plane by clicking on check. So we already selected the first one, the second plane, and now this is the direction of the top plane. So we can clear it, interrupt, redraw, get rid of that little red thing. Alright, so we want the intersection between the top plane of the first part 2. Click AND between that intersection, that plane, and what else do we want? We want the intersection of the plane to this side. So we could write the intersection of part 1 onto the side plane, which is, let us see. So we can either choose the start plane of part 2, or we can choose the far side plane of part 1. Let's choose the start plane of part 2. So still with part 2, start plane. And the third part, and the third one, so we have the plane over here, the plane over here. And let's pick one last plane. So we have this plane, we have this plane. So we form the line over here, that's the intersection, the line. And let's pick a middle one. So we'll pick the middle plane of part 2. Or, going back to our drawing, we want the middle one. So the center plane of part 2. So going back here, we pick the center plane. Now, once again, we can check it. If it doesn't show up, select the 2 planes and then click middle mouse button, and the check should show up. And here we have the origin. Good. That's exactly where we want it. Click OK, and we set the origin. Now for the vector x and vector y. Let's say we want vector x to be this way. So we go to vectors and just use these ones. So part x, part y, part z. We'll just use part x of the beam, of the second beam. So part x, once again, check it. Click on the first beam, click on the second beam, middle mouse button. Yeah, it's going in the right direction. Good. So that's our vector x. Click OK. Vector y, let's see. Once again, go to vectors. Now we want the vector y to be going down this way, which is actually the z-x axis. So it's actually the z-axis. First we want to pick number 2, then we pick part z. But for this one, the z-axis, the z-vector, the vector z is actually going upwards. We want to go downwards. So we just flip it by putting a negative sign in front of it. And then we check it. So click on the first beam, second beam, middle mouse button. And we can't really see it at the moment. We're going to have to hide this beam to see where the vector is. Going down. So that's good. Interrupt it. We got what we wanted. Redraw the view, and redrawing will cause the points to disappear, but we know where it is. So if you ever want to double check where the origin is, just click check again, and there you have it. So now we set our origin, x and y. Click OK. We'll set the parts for the bolts later. Now let's add a second one. Let's add shear plate. There we go, shear plate. Connection parts, once again, part 1, part 2. Connection bolt, that's the bolt connection, bolt used in the connection. These ones are optional, you don't have to enter anything for now. And that's it for the shear plate. Okay, now let's add a beam and set so we can cut the second beam according to the proper size. For the connection parts, we have connection part 1, part 2. For the bolt, we have this as a bolt, as our bolt. And for the shear plate, we have part 2-1 as our shear plate. So basically, main 0, main 1 is the main beam main beam and secondary beam. Part 1-1, the 1 corresponds to this one is the bolt, and part 2-1, the 2 corresponds to this 2 is our shear plate. Click OK. Now let's add a weld. Go to weld control to weld our shear plate. Okay, so first select the connection parts, so the 2 beams, the main beam and the secondary beam. Now, part weld to main part, part welded to. So what's the beam that we're welding to? That's the main beam. So main 1, main 0. Add part to be welded, the secondary part, which is our shear plate. Click OK, and that is it for our connection builder stage. Click OK, it will save. Go to set dialog form. Load up the connection macro we just made. Now let's first get some pages. So we have bolts, beam and setting, shear plate, and weld control and weld symbol. So first one we have bolt. So this will be our first page or first tab. Second we have let's put shear plate on the second page. So shear plate. It's our next page. And then we'll have and beam. It's our third page, and then we'll put weld control, weld on the fourth page. Okay, cool. Now let's edit this. So we'll put this on page number 1, edit. Now the pages go from 0 to onwards. So page number 1 is actually the number 0. Page number 2 is the number 1. Remember this. So this one will be on page 0. We'll change the label just so we know that we've edited it. And the next page is shear plate. We'll pick edit. Page 2. Shear plate. Oops. Shear plate. Set that. And then next page will be end beam setting. So edit this. And beam, page number 3. So we'll put set it. This one we don't need to worry about. We'll also put it on page 2. But we don't need to worry too much about it. And we'll just move this down a little bit, say 40, so that they all fit on the same page. Now we have weld control. We'll fit this on the last page. Put it on page number 4, which corresponds to number 3, and we'll put this over on Y10. And for this one, we will put it on the same page, but we'll go down a bit. We'll go 95. You will see why. Alright, let's try it. So, first page is the bolts. Second page is shear plate. Third page is the beam end. Okay, we'll change the name to weld control. Weld control and weld system symbol. Okay, check everything's all good. Okay, sounds good. Click OK. Now let's put our macro to the test. First, double click on this, select connection, select the connection we just made, click on the first beam, click on the second beam, and voila, we have our connection. So now we can play around with the coordinates. Let's interrupt, double click on this. Okay, for example, the bolt position. So there's the bolts in the X position, so this is the X, so there's 2 bolts in the X direction, and there's 3 bolts in the Y direction. The style is array. It's basically array just says name the number of bolts in one direction, name the number of bolts in the other one, and it will create an array of bolts. Alright, so this distance. Now when there's only one number here, it's the distance between the bolts. So this distance 3 is the distance in this direction between the bolts, and distance 3 here is the distance between the bolts. So distance in the Y direction, distance in the X direction. Now, if we change this to 4 and 4, or 4 and 5, you'll notice these bolts getting more spread. The Y direction is more spread than the X direction because 5 is greater than 4. These are in inches. Now we can change the quantity. We can change the number of bolts in a row to 4, and this is what we get. Cool. Now, if we enter 2 numbers in this separated by comma, the first number is how far the first bolt is away from the origin we specified, and these are all with respect to the origin we made previously or earlier on. So for example, if I write the first bolt is 3 away from the origin, and then subsequent bolts are 4 away from each other in the X direction, you see it came closer. We change this number to 2. You see it becomes even closer. Good. Because that's how it works. Symmetry by axis. When you have, say you have an axis right in the middle, if you have a symmetry, any bolt you put on this side will be mirrored on the other side along the axis. So if you have symmetry along x-axis and this is x-axis, bolts will be mirrored or symmetric along the axis. So these are the different styles. Feel free to test them out. So this concludes our video tutorial about the coordinate system used by Connection Builder.